Okay. So this class is 401. I have all of my slides in this PowerPoint. It's a compiled PowerPoint. I will be adding in more slides in it. And this would be uploaded on your account. So you can download it from your Moodle account and then you can use it for your reference. So this is the first class and I want to jump into the t-test, right? So first, if you look into the syllabus, there you'll find the topics which we need to discuss for this class. And one of the topic is t-test. The reason I am starting with t-test and some other topics is I just want to give you some introduction on what are these tests, what are the measures, descriptive measures, inferential test. And then once we have some idea on what these are, then we can jump into R, right? So the R functions to implement these tests on some sample data. So to start with, I have a slide on t-test. What is a t-score? What are p-values? What is the significance of test? And some assumptions, right? So t-test. So a t-test tells you how significant the difference is between two groups. Okay, so it lets you know if the two groups are they different or are they same, right? So the differences are measured in terms of means or average, right? So you need to know what is a t-test. A t-test measures if there are any differences between groups. Normally t-test is done on two groups, right? So if you have more than two groups, you do a different test called ANOVA. But for now, if you just have two groups, say you have the grades of classroom A and grades of classroom B, and if you want to compare the grades of classroom A and classroom B, and check if the grades are different or if they are same or if they are if they are high or low, right? So then that is where you use this test. An example of student test would be, so t-test is also called as a student's t-test, right? Just remember a t-test or a student's t-test. For example, a drug company wants to test a new cancer drug and if it improves the life expectancy, right? So you should have a control group and you should have treatment groups. So both the groups, we would be comparing them. So treatment group, you give your cancer drug, and control group, you give your placebo or just not a treatment drug. And then you compare the life expectancies of your treatment group and your control group. And then you apply the t-test, right? A student t-test to see if the means of treatment group are different than the means of the control group, right? So it's a very basic test which is used in data analysis. So just to give you a little more description of what that example is, right? So if you have like say a treatment group, and then if you have like a control group, right? So for treatment group, what you're giving is like a cancer or an anti-cancer drug, right? A drug which will treat cancer. So it's an anti-cancer drug. And then control group, you just give like a placebo, right? Which is just not any drug. right? So then what you do is you just find the life expectancy for your treatment group and for your control group, right? And then at the end, you just compare the life expectancies of your treatment group and your control group by a test called as t-test. And t-test, it looks into the means of your life expectancies. How different are the means for life expectancies of treatment group and your life expectancies of control group? Right, so this is one like very classic example of using a t-test um, uh, in in clinical trials, right? So this experiment is usually performed in trials, clinical trials, right? So you must have heard about clinical trials recently with this COVID pandemic, right? So in COVID pandemic, they had vaccines. So they give vaccines to treatment group and they give vaccines or no vaccines to your control group and see if there is a recovery of patients in treatment group and compared to control group. And here also you can use a t-test to compare if the vaccines are effective um, on your treatment group, right? So I can ask you, what is a t-test, right? What is a t-test? And give one example of a t-test, right? So t-test is it tells you how significant how significantly different your two groups are by measuring the group means. And the example of a t-test would be comparing the life expectancy of a drug, life expectancy uh, of the treatment group on a drug and a control group, right? That's all. So t-test, uh, if there is a t-test, there is something called as t-score, right? So t-score is a ratio between the difference between two groups and the difference within the two groups, right? So I'll ask you, what is a t-score? So t-score is a ratio between difference between two groups and the difference within the groups, right? So let's see. So if we look into another example, uh, right? So say you have two groups, right? So you have the life expectancy numbers for treatment group and life expectancy numbers for your control group, right? And let's say we have some data points here like patient 1, patient 2, patient 3, patient 4, patient 5, patient 6. And then life expectancy for control group also has like patient 1, patient 2, patient 3, patient 4, patient 5, and patient 6, right? So from these data points, you can find a difference, right? Say the life expectancy of treatment group, that you just take all these points and find a difference within this group. Say call it a difference number 1. Similarly, you take a life expectancy of control group and you find a difference within this control group, right? So now a t-score, right, according to our definition, is a difference between two groups and the difference within the groups, right? So it would be difference between two groups, which is D1 minus D2 divided by difference within groups, which is D1, D2, right? So it is the difference within two groups. So life expectancy differences within treatments is D1, and life expectancy differences between control is D2. So a T-score, according to our definition, is differences within two groups. So D1 minus D2 divided by differences within the groups, which is D1 multiplied by D2, right? So that's a T-score. So this is just an explanation, but then if I ask you, what is a T-score? So T-score is the ratio between the difference between two groups and the difference within the two groups. Large the T-score, more difference is between the groups. Smaller the T-score, less is the difference between two groups, right? A large T-score tells you that the groups are significantly different, and the small T-score tells you that the groups are not different. Okay, so from these two slides, I'm interested to know what do you mean by t-test? What is one example of t-test? And what is a t-score? And what does it imply? Right, so t-score is a ratio between difference between two groups and the difference within groups. Large t-score tells you the groups are significantly different. A small t-score tells you that groups are not different. Any questions so far? Any confusion?
Could you go back to the whiteboard with
Yeah.
us? And for the ratio, you did D1 minus D2 over, is that D1 times D2?
Yes. Yes. T1 is the difference between two groups. D1 minus D2 divided by D1 times D2, which is difference within two groups. We good?
Yes, sir.
Okay. Okay, so so that would be your t-test and t-score. The next thing which comes with t-test is p-values. Now you must have heard about p-values, right? So they are quite popular way of presenting your test of significance, right? So most of the research articles, they say that if the p-value is less than 0.05, then the two groups are significantly different. But if the p-value is more than 0.05, then you say that the two groups are not significantly different. But then what is this p-value? Why 0.05, right? So p-value is the probability that the results from your sample data occurred by chance. Okay, so what is p-value? A p-value is the probability. So P is for probability that the results from your sample data occurred by chance, right? So there's a reasoning why 0.05, right? So if the p-value is less than 0.05, you say that there is a difference. But if the p-value is more than 0.05, you say that there is no difference and the occurrence is by chance. It's random, but there is no reasoning if the p-value is more than 0.05. But if the p-value is less than 0.05, you say that there is a difference, which is because of two groups, right? So there is some variance in your data, something which is causing that difference. But if the p-value is more than 0.05, you say that it's just a random chance, right? It's a flick, right? So that's a p-value. So p-value is called as a probability value. Probability value that the results from your sample data occurred by chance. There are three types of t-test, right? So so just remember p-value and 0.05 threshold. Okay. So the idea is the p-value is less than 0.05. You say that two groups are significantly different. right? But if the p-value is more than 0.05, the two groups are not significantly different, and it's just occurred by chance. It's a random, right? So there is no meaning for it. But if it's less than 0.05, then there is some meaning. There is some some um some reason to it, right? There is some reason. So that's the p-value. And you definitely have seen this number 0.05, right? So it's a standard threshold for p-values, which is called as the significant threshold. There are three main types of t-test. So t-test can be classified into three types. First is called as an independent sample t-test. Second is called as a paired sample t-test. Third is called as a one sample t-test, right? So in the exam, I would be interested to know what are the types of t-test, right? So you should write, there are three types of t-test. One is called as an independent t-test, one is called as a paired t-test, and one is called as a one sample t-test. So these three tests, obviously, they look for different things, right? So they compare different things. The independent t-test compares the means for two groups. The pair t-test looks for means from same group. Okay, so independent is independent, right? As the name suggests, it's not dependent, it's independent. So if you're looking at two groups and you're comparing means, that is usually an independent sample t-test. If you're looking at means from same group, just one group, then it's called as a paired sample t-test. And one sample t-test looks at the mean of single group against a known mean, right? So this may be a little confusing, but for me to remember these three tests, I just look at the groups, right? So if I'm comparing two groups, that test is called as an independent test. If I'm comparing the same group within the same group, that is called as a paired test. And if I'm comparing same group with a known mean, right, with a standard value, with a reference value, it's called as a one sample test. Okay, so just a trick for me to remember these three tests is how many groups I'm working with, right? So if I'm working with two groups, it's called independent. If I'm working with one group, I call it as paired. And if I'm working with one group, but I'm comparing that with a reference, that is one sample t-test. That's all. Any confusion, questions? We good? So if you have any questions, please do ask. Right, so what is a p-value? It's a probability value, and normally 0.005 is your significant threshold. And there are three main types of t-test. First is called as an independent test, second is a paired test, third is a one sample test. If I'm comparing two groups, it's independent. If I'm comparing same group, it's paired. If I'm comparing same group with a reference, it's one sample. Okay, that's all. So those are the three types of t-test. So this is an example for pair t-test. Now, pair t-test is one of the very common t-tests which is used in biology and some clinical trials, right? So if we go back to this example here, right, treatment and control. Now these are some setups, right? Experimental setups which are very common. So people end up using some of these very same or similar type of t-test for those experiments. One of the t-tests which is very commonly used is a pair t-test or pair sample t-test, or it's also called as a dependent sample t-test. It's just the same name or different name for the same t-test, right? It's called as a pair t-test or pair sample t-test, or it's called as a dependent sample t-test, right? A pair t-test is where you run a test on dependent samples. Dependent samples are essentially connected. They are the test on the same person or thing, right? So I may ask you, give some examples for pair t-test. So a pair t-test is where, so from our previous slide, a pair t-test compares the means from same group, right? So I'm just working with one group, same group. So a pair t-test is where you run a t-test on dependent samples, which are essentially connected, like same person or same thing, right? Just one group, right? So the examples of pair t-test would be, if I just want to measure blood pressure on a same person using different blood pressure measuring equipment, right? So if I want to measure the blood pressure from the same person, the same is a very important keyword in pair t-test, right? So one person, and I want to measure their blood pressure using say one equipment or using two equipments or using three equipments, right? Three blood pressure measuring instruments, right? So, but the key word here is one person, same person. Okay. So I'll ask you, say, what is a pair t-test? So a pair t-test is where you run a t-test on the same person or same thing, or in other words, dependent samples. Dependent samples. And a few examples would be, if I want to measure the blood pressure of one person at different time points or with different blood pressure instruments, or if I want to measure the test on a same person before and after training, right? So these would be a couple of examples for your paired t-test. Any questions so far? Good. Okay, so the next thing is, we have more slides for t-test, and we will be using the R, right? The R software uh, programming package finding your t-test value, finding a p-value, right? For some sample data sets. So that is something which we should do today, setting up your R. So how many people have Mac operating system?
I do.
One. That's it. How many students have Windows?
I do.
Two, three,
I do.
four. Okay. Okay. All right. So you should be using the same computer, right? Same Windows or MacBook for the semester, because we will install R, and then we will install some dependencies, some libraries, right? So I want you to use the same computer and not to like use another one and then again install R and again install its dependencies, right? So just use the same laptop, same computer, and you have to use that for the exam also, right? So in the exam, I will ask some R questions. So you would have to use your R software to answer those questions. And so I don't want you to waste your time in installing dependencies if you're using a different computer on your exam. So so one thing which I want to do is, if you have the laptop with you today, then what you should do is you should just go into Google, and I'll give you the links to install your R software. Okay, so the most current version of R is 4.2.1. So if you're using Windows, go to this link. If you're using Mac, go to this link. Okay. So you have Windows, you have Mac. Anyone using Linux, Unix? No. So we just have Windows and Mac. So just go to this link. So if you're using MacBook, then just go to this link and click on this first package link, which is 4.2.1 package, right? So if you click on this link, then you would be install this package, and then you just click on unzip this package and then follow the instructions and just hit all the default options, right? Default, don't change any options for installation. Just select next, get all the standard default options, and finally it should be installed in, like, I don't know, probably like a couple of minutes. You should have it installed on your Mac. For Windows, you also do the same thing through the other link, right? So download 4.2, just click here, and then you should have the exe file, right? So with exe file, you just double click on this exe file, and then next, and you should be able to install R 4.2.1. So once you do the installation, just click on this icon, R blue icon. And once you click on this R blue icon, then you should be able to open the R console. On the R console, the first line should be your R version, which is 4.1.2 bird hippie. That's it. So do this now and let me know if you have any issues opening the R console. That's all. I'll wait for like a couple of minutes for you to install.
Mine installed, but it's not 4.1, 4.12, it's 4.21.
I see. Okay, because I have like an older version now. That's fine. Yeah, that's good. Okay, so please do this installation and let me know if you can open this R console. You give me a thumbs up if you are able to open this R console. Okay. Two more.
Mine is downloading currently.
Yeah, we'll just wait. Okay, so still installing.
No, sir. Mine just finished downloading.
Okay. Okay, so what I want to do is make sure you open the you are able to open the R console, and then you should be able to see R version 4.2.1, right? So mine is I guess one version back, and it's from 2021, but I think it's still compatible. But yours should be like 4.2.1 from today's installation, right? So once you do that, then I'll show you how to create a new R script document, how to save it, and then how to upload the R script document on your Git repository, right? How to push your code on your Git repositories. So, and then the first thing which you can start with is some of the functions for calculating your t-test, right? Because we are looking at t-test, paired t-test. So I'll give you some sample data, and then I'll show you how to calculate the t-test p-value using the R functions, and we will use some dummy data to do that. Okay, so make sure before our next class on Wednesday, you have your R running, and then we can just continue our t-test in the next class. If you don't have any questions, we are done. If you have questions, you can ask me now. I'll see you on Wednesday.